Hello and welcome to Empowered Learning. This video will showcase an application of computing probabilities. And so the purpose of this example is to make sure that we understand how to incorporate the fundamental counting principle inside of doing a probability problem. And so we got a lot of things going on here with this one. In essence, is a fairly simple problem, but when you read it at first, it seems to be a little bit more complex than what it has to be. And I wanted to go through this plus a few other examples just to make sure that we fully understand this concept of when do we use a probability, as well as when the fundamental counting principle comes into play. The difference in between using, let's say, permutation versus a combination, as well as when do we need to go to more rudimentary or primitive type of approaches to trying to figure out a particular problem versus trying to do counting without counting by using permutations and combinations. All right, so let's go ahead and get started with this example. So the example says that we have 8 sales representatives for a company, and they're to be chosen in some random, again, chosen at random for some training program. And so the company has 10 sales representatives in all, and 2 of them live in each region. And so you see I have the table there denoting that we have 2 that's living in each region there. So what we want to know is the probability that the 8 salespeople that we want to choose to go to this training program will only come from 4 of the 5 regions that are available to pick sales representatives from. Okay, so the first thing that we see is that we have a total of 10 representatives altogether, and 8 of them are to be chosen from these regions. Okay, and so in my first note, I say here that in order to pick the 8 representatives out of only 4 or 5 regions, we need to do 2 separate tasks. And of course, I put task in parentheses because whenever we have to do a succession of tasks, that is code word for we have to use the fundamental counting principle. Now, for those of you that may not be familiar with the fundamental counting principle, it's just a simple permutation that says the total amount of ways that we will do a particular task or do a particular thing is based upon the subtasks that are involved. So a simple example of this would be, let's say you want to put together a certain number of outfits. Okay. Now let's say you have 3 shirts and 2 pairs of pants, and you want to come up with how many outfits you have. Now most of you probably think of that and say, oh yeah, that's simple. That's just 6, right? Because you just take the 3 and then multiply it times the 2. You know, the 3 shirts times the 2 pairs of pants. Well, what's really going on there is that your first task is to pick which shirt that you're going to wear. And you have 3 choices. And so that's why you have 3 different ways of doing that task. And then the next thing is you need to multiply that by the number of ways that you can select a pair of pants. And since you only have 2, then that means you have 2 ways to choose. You can choose either pants number 1 or pants number 2. And so that's why we actually multiply those. And that's why, in that simple example, that's why we call it fundamental counting principle. Because we just take the first thing, multiply it by the second thing, and of course, if we were trying to add more stuff to that, we would just multiply successively. Okay. Well, in that same thing, we see in this problem that we actually have 2 things that we need to do. Since we're trying to only pick 8 representatives out of 4 out of the 5 regions, the first thing that we need to do is figure out the number of ways that we can select 4 regions out of 5. Because before we can even pick the representative, the first thing that we have to do is know which region we're going to pick them from. Okay. The second thing that we need to do is, after we've picked what region we're going to select a particular sales rep from, we need to figure out how many of those sales reps we are going to pick. And so in this particular problem, it makes it real simple because you have the same amount in each region. So since we have the same amount in each region, and we only can choose, a total of 8 representatives, 2 out of each of the 4 regions that we're allowed to, there's really only going to be one way that we're going to be able to do that. If we pick a region, then we have to pick both candidates or both sales representatives in that case. Okay, and so that's going to come to play in this problem in understanding how it simplifies and becomes easy, as well as how we could take this particular example and reword it a bit and rephrase it some so that we could see in other examples how if we don't have the same amount in each of the regions, how that would work. Okay. All right, so we basically have 2 tasks. So again, the first one is to pick which region, which of the 4 regions out of the 5 that we want, and then to pick the number of people within that region. Okay. Now, again, I'm saying that for this particular problem, since we know that we have to pick everyone within that region, it's really kind of redundant to actually go in and do the subtask that I say here for, let's say, selecting the 2 representatives from the first region, the second, the third, and the fourth. Okay, but I do that for clarity so that I could set it up for the following example that I'm going to do, where the number of people in the regions aren't necessarily the same for all regions. Okay, all right, so again, this note down here just says, since each region has 2 reps and we can only choose from the 4 regions, then we're forced to only have one way to pick it. Okay, and the reason why it doesn't matter, well, I'll put it like this: the reason why there's only one way to pick it is because when we get it within a region, we don't care whether we pick, let's say Bob first or Carly. Okay, or we pick Carly first and then Bob. At the end of the day, both have to be picked. And so since this is not a permutation type problem where order matters, then that is why there's only one way to pick them. You just grab them both and say, go to the training program. Okay. All right, so moving on here. The second note, we said since we will have to do successive tasks to help us find out our answer, we know that we have to use the fundamental counting principle. Okay. And since we're trying to find a probability, we need to define our event as well as the sample space of total possibilities. Okay. And so here, the reason I'm saying that is because of what we classically define a probability to be. A probability is basically a ratio of the number of times an event is successful over the total number of possibilities that you can have for that particular event or for that event to happen, the total number of ways it can happen. And so in looking at this particular problem, we know that the total number of possibilities to have that event happen is the same as its sample space. Okay. And if we define our event, in this case E, as being the event that a representative chosen for the training program is only from 4 of the 5 available regions here, then here the way that we can look at that is the probability of choosing a rep in a training program that's only 4 of the 5 regions is going to be the number of ways a rep is chosen from only 4 of those 5 regions divided by the number of ways to select 8 representatives from the total of 10 available representatives. Okay, and so the star that's in the numerator there is basically communicating that for this particular interpretation, this is where we could use the fundamental counting principle. Okay, and again, I mentioned that in this problem, we technically don't have to use it, but for clarity in the next example, I am going to use it so that you can see the similarities and differences there. Okay. All right. So here, if we keep on going, you'll see that the next thing I have here is I'm breaking down what my 2 major subtasks are. And so the first one is we have to figure out the number of ways to choose 4 of the 5 regions. And then after we know what particular region we're going to pick. Then we need to know the number of ways we're going to choose those representatives within each of those 4 regions. Okay, and then of course the denominator stays the same. And so I'll come here again and say the number of ways to choose only 4 or 5 representatives. That could also be translated as a combination of 5 regions chosen 4 at a time. Okay, and so I'm doing that because we need to bring in the combination computations into this problem. And so I'm trying to phrase it that way so that we can lead up to that. Okay, so we have this times, by using the fundamental principle, the second major task. And so you see I have all these things multiplied times each other here. And so if you remember, I said that there were some subtasks in the second major task that we had to do. And I'll go back to that quickly here. And so within these 4 or 5 regions, once we selected the 4 regions that we had to do, of course, we had to pick how many ways are we going to pick the 2 reps in the first region, and then the second region, and then the third, and then the fourth. So the notation that I'm using here is basically communicating that, hey, this is the combination of choosing 2 reps, 2 at a time for the first region, and then combination of choosing 2 reps, 2 at a time for the second region, and then the third region, and then the fourth region. Okay, so that's just my notation for that to try to make it as simple as possible. And so now we know that for this portion here, that's just going to be the combination of 5 regions chosen 4 at a time. We already know what all this is inside of the brackets, and then of course our denominator, the number of ways to select the combination of 10 representatives chosen 8 at a time. That would just be the combination of 10 things chosen 8 at a time. And so from here, if we move on, I just reiterate again that what was in the bracket there, I'm referring to all those subtasks for task 2 that we needed to do in employing the fundamental counting principle. And so now the next set of calculations is just saying, how do we actually calculate combination of 5 things taken 4 at a time by hand, and as well as all of these combinations, as well as the combination of 10 things chosen or taken 8 at a time as well. And so you see how we've calculated those. And here we're just using the basic formula. And I'll just go ahead and write it here. Our basic formula, that combination of n things taken r at a time, is just n factorial over r factorial over n minus r factorial. And if you're unfamiliar with how to calculate things in factorials, please check out my factorials video because I do go into that in detail, and it'll explain how we do this. Okay. So once we have these answers here, then you'll see that all we have to do is just plug everything in. And so we just have 5 times, and of course, for all those subtasks for subtask 2, there's only one way to pick them, pick the 2 representatives. So we just have 1 for all of these. And so then we end up having 5 over 45, which reduces to 1/9, and that is about 11.11%. Okay, if we want to translate that into a probability, into a percentage. And so probability wise, we would just keep it as 0.1111. Okay, and we're rounding to 4 decimal places there. Now, the extra insight that I want to give to this is that the way that we solved it is really not the only way that we could solve that particular problem. Okay. We could take a more primitive approach and look at it this way. So instead of looking at it as what is the combination of 5 things, take it 4 at a time, times, trying to be real fancy with the fundamental counting principle, we could just look at it this way. Of course, still, probability of an event being successful is the number of times that event is successful divided by the total number of times that event could happen. And so our denominator will pretty much remain the same. But our numerator, we see that instead of us multiplying by using the fundamental counting principle, we're actually adding in this case. And so I'm adding because we're looking at this in such a way to where, since we know we have, we can only choose 4 of the 5 regions, what we could do is just say, all right, well, let's say if we had a particular region that we omit, how many representatives do we have left in each region, and what is going to be the number of ways that we can actually select an arrangement of 8 representatives after we omit one of the regions. And so that's what the X1 and X2 and X3 stands for. And since we have 5 regions total, what we can do is just omit each one and see what the outcome is for each one and then add them up. So that is what the X of 1 through X of 5 stands for, okay? And so now what we can do is go through the thinking behind all of that, okay? Now, of course, in our example, we had 2 representatives in each of the 4, or each region, okay? So 2 representatives times 5 regions gives us 10 representatives total. Of course, if we omit one of the regions, we still have 2 representatives left in each region, and because of that, we also end up having a total of 8 representatives, no matter what region we omit. So it basically fits, what it is that we have to do here. So for each of those situations where we have X1, X2, X3, X4, X5, since the order doesn't matter in how we actually pick the representatives again, then there's only one way to do it. And so for all 5 regions, if that's the one that's omitted, we only have one way to pick all the candidates, which is just to pick all of them. So because of that, we still end up adding 1 to itself 5 times, which gives us 5. And then, of course, that's divided by still the combination of 10 things grouped 8 at a time. In this case, a combination of taking a total of 10 representatives and putting them in groups of 8. And we still get the same answer, okay? Now, I want to contrast a bit in this example by, revising this example slightly. And so the way that I'm going to revise it is by now making the number of representatives in each region not equal, okay? And so by that, you'll get a better feel for how we actually use this approach of adding stuff together versus the fancy fundamental counting principle type way, okay? So in this example, we have pretty much the same thing. Oops, let's get out of that. Let's try that again. So in this next example here, we have pretty much the same scenario here, but now you see that in region 2 and in region 3, we don't have 2 representatives, okay, sales representatives, okay? In region 2, we only have 1, and in region 5, we have 3. So we can kind of think of this as we had a particular sales rep from region 2 move to region 5, okay? So in doing this, we still want to know, all right, well, what's the probability now of having all your sales reps, the 8 that you need, come from only 4 of the 5 regions? So before we even think about this, because of the fact that we have 3 in this particular region here, the thinking here is that we have more flexibility on the different ways that we can choose candidates, so our probability may go up, okay? So we're expecting that our probability may go up slightly just because we have more than one way to choose candidates if we're trying to get 2 candidates from a particular region here, if we have 3, okay? All right, so with that, we know this problem is similar to the example that we had above. But of course, the one thing that's different is that all of the, well, not all of the sales representatives in different regions are different amounts now. It's just in region 2 and region 5 is different, okay? So when we look here, we can now define our probability this way, okay? And so if you remember in the extra insight part, instead of doing the whole fancy fundamental counting principle thing, I used addition and looked at it in a more primitive sense of saying, all right, well, if I omit a region, then what's my possibilities for what I have left? And so I'm using that same sort of thinking here. And so in doing it this way, now I have b sub 1 plus b sub 2 all the way to b sub 5. And so this is just my new notation for say, all right, these are the ways I'm going to pick 8 representatives from the 4 regions if I basically omit one of the regions. And so B1 represents region 1 being omitted, B2 represents region 2 being omitted, so on and so forth. Again, we see here that for our denominator is pretty much going to stay the same, okay? So we still have a total of 8 representatives that we have to choose from a total of 10 available to us. So that's not going to change. Now, if we keep on going here, we go through the scenario of each situation where we omit a region before we start choosing our representatives. Now, for region 1, we see that if we were to omit region 1, then the total outcome that we would have as far as the number of representatives that are left would be 8. So since we need 8, we would have to choose all of them. And so because of that, there's only one way to choose that. And I'll go back here just to be clear. So let's say we omit region 1 here. So we just take that and cross that out. Well, what we have remaining is 1 plus 2 is 3, 3 plus 2 is 5, and 5 plus 2 is 8. And so since we have to have 8 representatives coming from 4 regions, and that's what we have left here, then we have to pick everyone. So there's only one way to do it, okay? So that's what I mean by that. If we look here, if we do the same thing for region 2, you'll see that for region 2, however, if we add all this up, we got 2 plus 2 plus 2, which is 6, plus 3, which is 9. We have 4 regions, but 9 representatives, okay? Now, since we need basically 2 representatives coming from each region to get to our 8, we know that there's only one way to pick stuff from region 1, one way to pick it from region 3, one way to pick it from region 4. But now here, we know that for region 5, we have 3 representatives, but we only need to choose 2. So that tells us this is the combination of 3 representatives chosen 2 at a time. And if you do the calculations on that, you'll see that the answer to this is 3. So in using the fundamental counting principle in this example, there's only one way to choose region 1, one way to choose region 3, one way to choose region 4, but there's 3 ways to choose region 5. So if we multiply all that together, we end up getting 3 for that particular possibility, okay? So that is how, even within this, the fundamental counting principle is used. So we'll see here that, let me get rid of this. So we'll see here that for region 2, we have this possibility of having more flexibility there, okay? Now, let's get rid of all this and look at some of the other regions, okay? So we've looked at region 1, region 2, and just region 2. Now, if we look at region 3, then of course, we see that we have 2 plus 3 is 5, and then the 2 plus 1 here, which is 8. So we're in the same situation as region 1. So here basically what we're saying is that if we exclude region 1, we only got one way to do it. if we have exclude region 2, we had 3 ways of doing it. If we looked at region 3, then as excluding that, then it's just like region 1, okay? And then of course, here we can do the same thing. Oops, let's get rid of that. Let's get rid of that. For region 4, if we take care of region 4, we have the same kind of thing. So we got 2 plus 1 is 3, plus 2 is 5, plus 3 is 8. So B4 is the same thing, it's just 1. Now for region 5, we'll see that, let me do this here. For region 5, if we get rid of region 5, then we have a strange situation here. Because now, if we add up all the numbers, we only have 7. And so we need 8 representatives. So since we need 8 representatives, and if we exclude region 5, we only have 7, that tells us that there is no way that we're going to send 8 people to this particular training program without picking someone from region 5. It's impossible to do, okay? So because of that, we're going to say that if we omit region 5, there's 0 chance that that's going to happen, okay? Or no way that's going to happen. So if we take all this and now look at what we're asked to do, we can just add all these numbers up, okay? And so I'm going to go back to where we were here. And so this explanation here just goes into saying all the stuff that we just got through talking about, which is if we exclude region 1, then of course there's only one way to do it because we have 8 candidates left, or 8 representatives left. And so the same situation happens with excluding region 3 or excluding region 4. For region 2, we see that we have 9 candidates left when we exclude region 2. And so because of region 5 having so many representatives in it, we have 3 different ways of choosing all of our 8 representatives instead of just 1. And then of course, for the last one here for region 5, we know that because it has 3 in it, we're not going to be able to send 8 people to the training program without having someone from region 5. So to put this all together, we see that we add up all the numbers now, and instead of having 5 over 45, like what we had whenever we did the probability of this event, for example, 1, now we have 6 out of 45, which means our probability went up a bit, okay? And so of course I just reduced that, and we see that instead of it being like a little over 11%, now we're about 13.33% chance of this happening. And mainly that's because, again, we know that we have to pick someone out of region 5, and we have multiple ways of doing that versus just one way. So it increases our probability, okay? And so with this, that concludes this example of applications of probability. Thank you so much for paying attention to this video.